you for taking the time today. So can anyone guess what those opportunities might be before I get started? Okay. Well, I'm going to take you back in time a little bit. So here we are today. Several of you are experienced fleet managers, some may be new, and you may remember a time when you were struggling to get buy-in within your organization to plug these devices into the port of your vehicles so that you could track and trace. It's kind of hard to believe that that was 60 years ago when GPS technology itself was invented, and almost 35 years ago before it was made publicly available. And now we're fast forwarding through the times to 2014 where full connectivity begins, and since 2017, more than half of new vehicles are connected to the internet. So GPS then was really invented to, track asset positions and improve communication in the battlefield. But GPS now shapes businesses today. We're all thinking about how we can reduce costs of fuel as it pertains to idling. We're thinking about how we can optimize our fleets. Maybe we should consider asset sharing between other fleets based off of the utilization. We're being faced with different ways to operate our fleets as new compliance regulations are being introduced. But times are changing, and there's even more coming our way as to how we can manage our fleets. We can go from reactive fleet management, where we're outing fires, we're addressing day-to-day issues, and quickly trying to implement policies that can make an improvement down the line, to tools that allow us to make proactive decisions on how we can manage our fleet. So a simple example is today you have a driver, they have a truck, it's full of product, ready to go out to a customer, and they have a breakdown on the side of the road, they gotta call roadside assistance, they have to tow the truck, there's all the maintenance costs associated with that. What if there was a way to predict that that event was gonna happen ahead of time? Well, through technology, we have ways to do so. It's predicted that by 2025, there will be 75 billion IoT connected devices worldwide. All of these devices connecting data and being sent to servers and the internet everywhere. Being stored on cloud, in premise, you have big data that's being cleansed, analyzed, and being built into AI algorithms that can be used just like the human brain. It can develop its own patterns and make decisions based off of new situations. This is going to change the way that fleets can run their businesses. So fast forward to the future where we have a vision of connected fleets using AI, different forms of machine learning such as supervised learning. Geotab did some pilots with customers on intelligent zone classification. Several of you may have customers where you have addresses of those customers that you have to download manually. You don't know how accurate those addresses are. These addresses are being used to manage your routes, optimize your deliveries, but how do you know that your vehicle is actually stopping within those geofences? You could have a customer that is a store location and you have a square or circle geofence around it, but really the guy, every time he drops off the product, is parking across the road. You're not capturing the time in and out of that customer accurately. So we've used AI to analyze patterns and trends and combine telematics data with routing data to figure out where the vehicles are actually stopping and develop smart geofences so that you can improve your customer locations and thus improve productivity long term. Another example that data.geotab.com offers is we have classified vehicles. Someone asked about vocation as it pertains to EV fleets. Very important question. We have different industries that are operating their fleets. We have 1.7 million devices connected, and we want to be able to leverage that data to benchmark our fleets to similar ones. So by analyzing the patterns of how these vehicles behave, we can classify them into these vocations. So here we have an example of the office worker where we can see the primary activity is in the morning and in the evening when they're commuting to and from work. We have a school bus where you see activity mid-morning to mid-afternoon. And then we have delivery service fleets where we can see that there's activity throughout the day because they're making those stops. This can be used to compare your fleet to similar fleets, and vocation is a very important aspect of benchmarking that can help with that. Some other examples, and just for everyone to be aware, these are open data sets on data.geotab.com that are crucial to improving your productivity. So hyperlocal temperature, Colin touched on this. Instead of getting the weather data that's reported from a particular weather station, you're getting more granular information of specific geohashes. That can be used to transform the way you do trip routing. You can avoid current and predicted weather conditions and make sure that your drivers are getting their deliveries done without running into poor weather conditions. Road impediments, driving on bumpy roads with tons of potholes, that's a lot of wear and tear on the tires, a lot of maintenance that has to be done. We've used the accelerometer data from our telematics devices to identify these areas. Another area that you can improve route optimization. And then parking availability. So are you planning where your asset is parking when it goes to do a delivery? We looked at the data and we found that there was different amounts of searching for parking waiting time. So we can see the assets are moving around in different locations and they can't find somewhere to park. This helps both cities who can use this data to help improve their infrastructure and fleet managers so that they can look for areas where there's better parking and advise their driver so that they cut down the costs on looking for those parking when they get to that location. So where do you start? Some of you, when we took the survey, a few of you have already started implementing big data or AI projects in your fleets. Others of you may not have heard of it before, but there's two ways to look at it. There's the top-down approach where typically you'll be, what's the big data problem that you want to solve? And beforehand, you're not really thinking about where do I get the data to solve for it. And then there's the bottom-up approach. You have your nerdy folks in the office that know we have all this type of data. They're thinking of these out-of-the-box opportunities and how they can solve these big data problems. But that can easily turn into a research project that's not tied back to saving money or adding value to the business. So the real big data opportunity lies by meeting in the middle. So you're looking at your corporate objectives, you're looking at what keeps you up at night, and then you're also taking a look at what data is available. But that's not just your data. It's not the internal data, it's not the telematics data. There's tons of open data out there that you can leverage to make this big data opportunity that more rich. So an example of driver safety. So here we used internal data such as telematics data, external data like open data, and then intersection insights from data.geotab.com. So I'm going to walk you through an example. Here we have a depiction of two routes. Maria and David appear to drive very similarly when we compare their harsh driving behaviors. They both have 2 hard braking events and 2 hard acceleration events, and they both have similar miles driven. But what wasn't taken into account is, were they traveling in hazardous driving areas? So we've used the accelerometer data and the harsh driving events from our 1.7 million devices to be able to identify areas across the world where there's hazardous driving areas. So as we can see, Maria drove in an area with 3 hazardous areas, whereas David had none. This means that different driver feedback is required. Maria drives well in hazardous areas when compared to her peers, but David drives poorly when driving on the highway. You can't be measuring these drivers by simply just the number of incidences because there's so many other factors at play, and that's how big data and AI can help you improve your fleet. So really the importance comes in being able to take action on those results. So you have the data collection, you're building this data lake, a very key component. In order to make these decisions for big data and AI, you need to have a fair amount of data so that the machine can learn the behavior. And people and processes need to be built in to these discussions so that you make sure that you're focusing on the right topics. Colin mentioned, you can't work in silos. Yes, if you don't have the big data resources, you might need to get a partner to come on board, but you guys are the expertise and you need to give your opinion and work together to solve these big data problems. And when you're looking at those big data opportunities, you need to say to yourself, as a result of this, what action can I take? So in the example of Maria and David, we would want to look at our policy design for safety. We need to evaluate the driver scorecard and start taking into account these hazardous driving areas. Drivers will not simply just be measured based off of a number of instances. And then, once you see the results of these big data pilots and opportunities, you need to monitor them. You implement them, you tweak, you adjust. And that's how you're really going to see the true ROI and see if this should be an integrated solution full time and these changes should be implemented. So I'm going to pass it over to David Escobar from Navisaf to talk you through a real life case study.
Thank you, Sabina. Hi to everyone, thank you for attending this. Basically, Navisaf is an add-value reseller for Geotab and has experience based on OEM, Navisaf internationally, and safety experience based on a psychologist team and logistics working with all of our customers. So basically what we are going to speak here is about, I need to make a click inside your minds. Understanding the risk in a way different that we always handle the risk. We have charts, we measure harsh braking, harsh acceleration, idling, all that stuff related with risk, speeding as the first and most important KPI. But at the end, you start to see something like this. This is the twilight zone. Why happened the accident? Why is that? Why if the driver was the perfect driver has an accident? So at this point, no one's know why, and you start to make forensic in each accident to understand that the 80% of the accidents occurs under the speed limits of each street. So when you are working around this, we have found something very interesting. So what we have done here, for example, this is something that happens last week, and I like to put them on the table just to show you what happens here. This is a truck for a customer of us. The accident was at 60 miles per hour. And take a look over the truck. It gets destroyed. And no one's understand why happens that. It was so slow the speed, and the truck gets destroyed, and the driver of course dies. It's a shame that it happens. And why is that? When we run big data, we have a model where we identify every harsh braking and every harsh acceleration in the last 12 months. And we identified that all the vehicles passing through a specific zone, some one of them has an event of harsh braking or harsh cornering, the other ones doesn't. And we calculated the average speed of the ones who has not an event. And we redefined a new speed limit based on the experience of the fleet and the topology and the architecture of the road. So we are redefining the speed limit of each street, taking care about all the environment, not only the speed limit. It's the cargo. What happens here was the truck, the trailer truck, takes a hole. It was full of cement. The cement have a liquid behavior, and the trailer dumped the tractor and crushed the cabin. That's what happened, and that's why it was at that low speed. When we go there and run a query over a year and find out what happens at that spot, we find out that the vehicles passing over 10 or 15 kilometers per hour, that can be 7 or 8 miles per hour, don't have any problem. But this guy, at that day, at that specific moment, has a bad luck and crashed himself. So basically, the question is, this accident can be prevented? The answer is yes, but we are not doing the right work, because over our concept is redefining the way that you are measuring the speed limits. Your topology and your product has a specific behavior. So if you make big data and redefine the speed limits in each street where your fleet is exposed, you are going to have another different limits. We are working this with Lafarge Holcim and PepsiCo, and the results are really nice. But in some other customers, you have some problems that I'm going to take later. So basically, what is the roadmap? Make the query of the risk zone, braking and cornering, extract of each event and calculate the average speed of each risk spot. Then you search the vehicles who pass over that point without an event and take that average speed as the new speed limit at that zone. After that, you load that zones over geotab solution, my geotab standard solution, and create the geofences. So now, over my geotab, you have the new speed limit in each street. So you don't have to be measuring every harsh braking, every harsh cornering. You just have to focus on speed in each zone, and that's it. It's more simple. So another question that is coming is, okay, and how my driver understand what is the limit at that spot? That's why we developed an application, an app. So that application runs offline. Every day, the application connects to my geotab and download every zone. And the driver just like GoTalk device works. Everyone knows the GoTalk device from geotab. That is the one who's speaking in the cabin. Okay, so basically this is an application that we have made for the driver to understand by voice and an image what's the limit of each point of each street. So based on that, the driver knows at what speed he has to go in each zone offline, because of course we don't have coverage in all around the roads and all around the countries. So that's why it's offline and the database is not very daily. And based on that, the drivers get the feedback that they need. So, of course, some of you, maybe some companies in some countries have labor union problems. And because of that, we have developed a speed governor. That is a hardware that you install in the vehicles that works over the accelerator pedal or the fuel pump, and is a Bluetooth device. So they connect to the smartphone, and the smartphone sends the speed limit in each zone. So the accelerator pedal stop working if the drivers try to overspeed that zone. That is more coercive, but in some cases, some customers ask for us to ask. So it's capable of, if you have the culture and you don't have any problem imposing just the smart app and the BigQuery application that we have, it's okay. But if you need something more coercive, we have a product to do that. So this is a small video that works how limit the speed. I don't have the audio here, but okay, in some points, I can share this video with you. Basically, is the device limiting the speed. Something very important here is that it is fail-safe device. They takes the RPMs of the vehicle. So if the RPMs goes under 700 RPMs, the devices stop working and stop limiting, because the vehicle can shoot down and no brakes and no steering wheel works. So it's very secure and it's developed by Navisaf.
Not safe.
So, Sabine, let's make it close. Basically, the invitation here is to have an approach, a different approach related with safety. It's not make the scorecard based on harsh braking, harsh acceleration, and a lot of amounts of variables. Keep it simple. Keep it in just the speeding zones, calculated based on your own experience of your own fleet, on your own cargo, and based on that is going to be an easy message to your drivers. Of course, if you work with this, you are going to hit less the brakes, and that is fuel. So the cost effective and the ROI is going to be faster only with this point, because if you get a lower speed, you hit less the brake, you are working on your risk zones, and of course the fuel is going to be way better.
Yeah, and to David's point, really it's all about the journey. There's tons of big data opportunities out there, but if you haven't started already, you want to start with the one that makes the most sense and is going to have the most impact first. So make sure that you're looking at how you can drive action from those results and start there. And make sure you're leveraging tools and data that are open source to help you with that. There's more than just within your internal data and your other department data. There's a wide variety of data out there that can make that big data opportunity richer.
Excellent. Do we have any questions before we say goodbye to David and Stefan, not forever, but into the audience? Yeah, when I come to you. If you can just give us your name and where you're from, that would be great.
I'm Tim Rivera with DHL Express. Quick question on your software there, your app that you show with the PDA or the phone. Have you integrated that with any organizations, proprietary solutions that they have, such as PDAs with their own software?
Sure. It can be done, and only depends on the OS of the PDA, but we can do it.
Another question out there? So overwhelming, big data, artificial intelligence, it's so futuristic. No? Okay.
It's something that I want to add here.
Please.
Is that the transportation is in ABC. Simple. You have an uptime, you have to ensure that uptime. What is that uptime? Mechanics and safety. And based on that, for example, what ADMB has done with 10% less kilometer per hectoliter delivery, that is a huge amount of money in logistics, can be made only because they have a mechanical uptime and a safety uptime already done. And they have maybe 4 years working on that to get that uptime. When you have that uptime, you can use your fleet more and more and more. But if you don't handle risk in a simple way, of course you are going to have losses, huge losses. So that is the ADC, basically uptime based on mechanics and safety, and then you use that uptime in an efficient mode. And that's our expertise.
Excellent. Thank you so much to both of you. Thank you very much. Okay, I'd like to invite up our regional panel now. Steph is going to be moderating.